All right, calculus. We are in the review part of the year. We're going to be looking at the sample test. Here are some solutions worked out for you guys. You can see them as they're going, and I'll try to annotate them as well. Let's start out with something easy. The first question on the AP test every year is almost always very easy. So kind of expect that. Don't overthink it. This one's very mechanical. As you look at it, all you're really trying to do is just take an antiderivative, do the integral, and evaluate it from 0 to 2. So look at each of these terms. I know I can do them separately because they're added together here. Because it's adding, I can do the first term just by itself. The antiderivative of 2x to the third power is going to become 2x to the fourth power over 4 by basic power rule. And 3 is going to become 3x, also by power rule. And we're evaluating that from 0 to 2. Something I've been working with you guys on all year is if you notice this is a 0 on the bottom, and there's an x term in each, or an x in each of the terms, then you don't have to really worry about the 0 part. Because when we subtract the bottom, that's going to be 0 when I plug it in, and that's going to be 0 when I plug it in. It works for both of them. So I just need to plug in the 2. That means I have 2 times 2 to the fourth power over 4 plus 3 times 2. Well, the second term is 6. The first term is going to be 2 times 16 over 4. That 16 and 4 becomes 4 and 1, so that means I just have 2 times 4, or 8 plus 6, which is 14. C would have been the correct answer. Number 2. For this one, let's zoom it in just a little bit here, a little bit bigger. Okay, let's not get too confused at all this stuff talking about differential equations and the slope field. The slope field is when you have an x and y axis. Let's draw that a little bit neater. When you have an x and y axis going like this and like this, and it's asking you when are you going to have, if these were like some tangent lines, more tangent lines, and then more tangent segments, and so on. It's asking you when would it be vertical. So the question that you're trying to answer then is not so much looking at the slope field and its specific little segments, but think about slope in general. This represents slope. And if it's asking for vertical segments, that means the same thing as vertical tangents. Now there's 3 possibilities as far as specific or like exceptions to slope other than it being positive, negative. It's either positive or it's negative, or the other 3 exceptions is it's vertical, horizontal, or it's a hole in this ratio here. So to be a hole, that means you get 0 on top and 0 on bottom. To be horizontal, meaning flat or a horizontal type tangent, that's 0 divided by some number. And this number right here is not 0. And for a vertical line, that's some number over 0. And again, that number is not 0. So what we want to ask ourselves if we're looking for vertical type lines is how do we make the bottom equal 0 but the top not equal 0? Well, let's go ahead and set up this piece down here, xy plus 5x, and find out when that would be equal to 0. So xy plus 5x equals 0. If I factor out the x, I'm left with y plus 5 inside the parentheses here. And that tells me by zero product property, where I'm multiplying 2 factors equal to 0, that either x equals 0 or y equals negative 5. Well, just going off those quick assumptions, it looks like E is our most likely candidate. The only thing I need to check is if I were to plug in either of these values, either 0 for x or negative 5 for y, what would that do to the top? Would it make it 0 as well? In this case, it doesn't. So therefore, our answer E is correct. Number 3. Okay, whenever we see words like continuous, those seem to stand out. So when it says, suppose that f is a continuous function defined for all real numbers x, that matters. Why do I know it matters? Because I know after reading tons of these questions that they don't just say those kind of things just for fun. And we know that f of negative 5 equals 3, so if I were to look at kind of an x and y axis, just a quick sketch of kind of what we're looking at here. We know that at negative 5, we are at 3, probably about here. And at negative 1, we are at negative 2, about down here. And it says this line is continuous. And for that line to be continuous, that means it's going to connect from this point, let's call that A, to this point down here, B. And for those 2 points to connect, that means we also somewhere in the middle cross the x-axis, meaning that f of x, the function, is equal to 0. And that's what it's actually asking us. If this function equals 0 only once, in other words, it doesn't do this, what I'm about to do in the gray. It doesn't go down and then come back up and then go down again. It only does it once. Kind of like this black line here. Then which of the following could be x? Well, notice that if it's going to cross here, that means, or actually it's also saying that maybe what if it goes down and comes back up and goes up here again and hits it later. Well, it's not doing that. It's saying that it only crosses once, and if it only crosses once, that means it has to cross right here between negative 5 and 1. Between negative 5 and 1 is the key, because only one out of all of these lies between negative 5 and 1. It's B. A, C, D, and E are all outside of that interval. Therefore, they don't apply. Let's look at the next one. Here is an example of when it's actually better for you not to simplify. So when you look at this problem, it's asking us to take the fourth derivative. We're going to do that, but we're not going to multiply and simplify our terms together. We're just going to leave them as is. So let's start with the first derivative. This is a chain rule, which means I'm going to take the derivative of the outside and then multiply of the inside. I'm going to take derivative of the outside, just rewrite the inside, and then multiply it by the derivative of the inside. So if I were to take the derivative of the outside, let's go ahead and write that in blue. So I'm pulling that 4 down and leaving the 3 up here. And I'm also going to multiply it by the derivative of the inside, which is 3. Then I just rewrite that inside right in here, 2 plus 3x. If I want to look at the second derivative, I'm going to follow the same kind of pattern, but I'm not going to simplify this 4 and 3. I'm going to leave it there. So that's 4 is a constant there. This 3 is a constant here. But now let's do the second derivative in red. The 3 is going to come down, so that comes down in front. We leave the inside alone, and this 3 is now subtracted 1 on the power. We have a 2. And we also have the derivative of the inside again, which is 3. So we have this 2 plus 3x still here. So we're doing that chain rule. We're taking derivative of the outside, rewriting the inside, but then multiplying by the derivative of the inside. Now you guys might start to see a pattern here. When we get to the third level, we still have the 4 here, the original 3 from that first derivative, then from the second derivative we have a 3 with the 4 and a 3 with the 3 out here. Now we're getting to the next derivative. We're going to take this 2, pull it out front, and the power up here is now 1. And we multiply by a derivative of the inside again, and that's another 3. We have 2 plus 3x on the inside. We keep rewriting that. For the fourth and final derivative here, most of our pattern stays the same. We have 4, and we have this 3. And we have times 3 on the front and on the back. Then on the front now we have a 2 and another 3 on the back. Now for the last one, let's do gray. It's going to be times 1 to the something times 0 times to the 0 power. So we got 2 plus 3x to the 0 power. This right here, this whole term in the middle, now that we're at the fourth derivative, this is actually just 1. So we have 4 times 3 times 2 times 1. Oh, whoops, we almost forgot something. Times the derivative of the inside here. We needed that other 3. Times 3 times 3 times 3 times 3. Now if I were to simplify this finally, I'd get 3 to the 4th power here and 4 factorial here. That gives me C. So that middle term, when we eventually got to the 4th derivative, became a constant because it's to the 0 power. At what value does this function have a relative min? Whenever you hear relative min, or even min or max of any kind, you should be thinking first derivative, because that's going to tell you slopes, and slopes help you interpret mins and maxes. So as I'm looking at this one, I want to find the derivative. F prime of x would be 4x cubed minus 16x. Now if I factor that, I can pull out a 4x from each term. I'll be left with x squared minus 4. And if I keep factoring, I'll still have that 4x, and then in here is a difference of squares. So it's going to be x plus 2 and x minus 2. And again, by zero product property, we can apply that here. Why would I be setting this equal to 0? It's because I'm looking for critical points. That's when the derivative equals 0, giving you horizontal tangents, or when the derivative does not exist. Well, this derivative is a polynomial. Polynomials and the derivatives always exist, so we are focused then on just when does it equal 0. Well, since we're trying to set it equal to 0, we can say by zero product property that x equals 0 or plus or minus 2. That being said, now we know we have 3 candidates, but we're being more specific. We're asking ourselves, when is it a minimum? Not just any extrema, but specifically a minimum. If I do a quick chart here, I can see when this function is actually going up or down, and what the shape of the original graph looks like. So the x values that I want to check, I need to check -2, I need to check 0, and I need to check 2, but I also need to check in between those. So I'm also going to check 1, -1, and -3 out here, and 3 out front as well. So let's make a little chart. Splitting this up for ourselves. We need some vertical lines. Make it look somewhat neat. Okay, so I know that at -2, 0, and 2, the derivative is 0. That means that those 3 spots are flat. Now I'm going to plug in these other 3 and see what happens, or other 4. If I plug in -3 into this, if I plug in -3 into the first term, that's a negative. So it's going to be a negative times a negative times another negative. 3 negatives, that makes negative. That means our function is going down. Then when I plug in -1, that's going to be negative for the first term, positive for the second term, and negative for the third term. Multiply all those together, you get a positive value, which means that our function is going to be going up. When I plug into the 1 into this, I'll get a positive, then a positive, and then a negative. That means I'm going to go back down negative, And then this last one here is going to be positive, 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 which means I go back up. So I hope that you can see we would have a minimum here and here as well at plus or minus 2. But not at 0, because this is a max at 0. It goes up on the left, down on the right. It's increasing and decreasing. The derivative changes from positive to negative. So that means 0 is out. Well, if we just looked at that, that actually eliminates everything except D. So there's our answer. Number 6. This one is a lot easier than you would think if you just do algebra first. Algebra first. Do some simplifying ahead of time with the expression. Because when I look at this expression, I see one function times another function. It's difficult to integrate f of x times g of x. This is very hard. It is much easier to integrate f of x plus g of x, because then I can do each one separately. This is what I want. In order to get it there, I just got to do some algebra, some simplifying. First thing that I'm going to look at is the integral of square root of x is really going to be x to the 1/2. And we're going to have x plus 2 here. And what I can do then is I can distribute this x to the 1/2 to the other terms inside those parentheses. Then I'll get x to the 3/2 plus 2x to the 1/2 dx, of course. Now that I have it in a situation where I have two functions added together, I can do each one separately. These each are power ruled. Yes, they're fractions, but they're still power ruled because it's x to some power. And the integral of x to some power dx is just x to the n plus 1 over n plus 1 plus c. So 3/2 plus 1 is 5/2. So that's x to the 5/2. I'm also going to divide by 5/2 as well. Plus 2x to the 3/2 over 3/2. And we have plus c. Now if I were to simplify by taking these fractions on the bottom and flipping them, that would make it 2/5 x to the 5/2 plus 4/3, because this 2, when I flip it up, it's really 2 times 2, x to the 3/2 plus c. Well, the answer then must be D. For duh. Alright, this one. This is one that is so easy if you remember what this actually means. What the limit as h approaches 0 of f of x plus h minus f of x over h equals. The limit as h approaches 0 of f of x plus h, some function with x plus h, minus that same function but with just x, all over h. That actually equals the derivative of f with x applied to it. Then what we're looking at is we want to find a simple way to connect this term here that I'm boxing in blue with this term here, which is our answer, in red. What's the connection? It's the derivative. But I start with that blue piece, so I'm going to look for that blue piece, which is right here. So that means that f of x equals absolute value of x, which is actually a piecewise function. That means that it's x if x is greater than 0, and it's negative x if x is less than 0. It's a piecewise function. How do I know that? Well, experience. But I could even just figure it out just by looking at the picture. It's a piecewise function where we have two lines that intersect at the origin. They look like this. We also know these slopes. They're pretty straightforward. The slope of the one on the right here. Oops. Take that back. Try to erase this piece that we just drew. There we go. The slope here is just 1. And the slope on the left side is negative 1. But if I wanted to think of that as a derivative from this piece here, f prime of x is also a piecewise function. The derivative of the top is just 1. The derivative of the bottom is negative 1. If x is greater than 0 and if x is less than 0, respectively. So then I just need to figure out what's going on with this function, with this expression, at this point x equals 3. Well, I know that the limit of this function is really just the derivative. So it's asking me, what is f prime of 3? That's it. Then I'm just asking myself, what's the derivative? What is the slope when x equals 3? It's over here. And the slope equals 1. The answer is C. Number 8. This one has lots of pieces to it, a lot of extra algebra that we're going to be seeing, but two key things that we need to see at the very beginning. Vocabulary, horizontal tangent and point of inflection. Whenever you hear the word horizontal tangent, what does that mean? That means that the first derivative equals 0. And point of inflection, what does that mean? Well, that means that there's a change in concavity. And if there's a change in concavity, that means that the second derivative is equal to 0. That being said, we can take this original function and we can find its first derivative and second derivative and see what they are and set them equal to 0 and solve backwards to figure out what b is. So let's do that. Y prime, our first derivative, is going to be 4x cubed plus 2bx plus 8. Y double prime is actually the derivative of that. And that's going to be equal to 12x squared plus 2b. Now something interesting happens here because we know that the first derivative equals 0 and the second derivative equals 0. So let's use that information to help us solve for b. If I look at the y double prime, the second derivative, that's a little bit easier to deal with. So I'm going to have 0 equals 12x squared plus 2b. By doing a little bit of algebra here, we can get negative 2b equals 12x squared divided by negative 2. We get b equals negative 6 times x squared. I'm going to use this and I'm going to plug it in for b here. That means to me that y prime equals 4x cubed plus 2 times b times x plus 8. Well, b is negative 6x squared. If I were to simplify that, I have 4x cubed plus, well, 2 times negative 6 is negative 12. And x squared times x is x cubed plus 8, of course. If I simplify this even more, that gives me negative 8x cubed plus 8. And I know that this is y prime, but I know something about this. Because in both of these situations, we know that first derivative equals 0 and second derivative equals 0 again. So I'm going to set this equal to 0 and now solve it. So I have 8x cubed equals 8. Divide both sides by 8. X cubed equals 1. X equals 1. So is that my answer? Is the answer C? No, it's not. Because it wasn't asking me for C, it was asking me for B. Ah, look at this here. B equals negative 6 times x squared at this point that we're talking about. So if x equals 1, then this is going to be negative 6 times 1 squared, which is equal to negative 6. The answer is A. Those details matter. So you always got to check and make sure that you're answering the question that was first given. Alright, last one for this video. If y equals 7 is a horizontal asymptote, that means it's a vocabulary word that we need to start looking at for the rational function f. Horizontal asymptote. If we're looking at horizontal asymptote for any function, whether it's rational function or not, that means that the limit as x goes to infinity of that function is equal to that number. In this case, 7. That was pretty straightforward. That's E. But how do I know it's not B? How do I know that's not true? Well, I know that E must be true, so it's hard for me to even consider B when I know that E must be true. Well, if I'm looking at B, sometimes that works, but the thing that you have to consider is that when you're looking at negative infinity, at negative infinity, the limit as x goes to negative infinity, when you're doing this, the square root of x squared does not equal x. Because x is a negative number, and this is positive, while this is negative. That tells me that I don't know. This is a question mark. B is a question mark. I don't know if it must be true. Maybe, but we don't know if it must be true, so then I'm going to stick with E. E is my answer. Alright, that's our first video. The next one will be coming up shortly.